So what we have given to us here is we have standard position angle, terminal elements in quadrant 3, and the value of cosine of theta. Question's asking us for the exact values of sine theta and tangent theta, and we have enough information, even though it's been disguised a little bit, to find this. As always, we need to draw out what this angle looks like. So quadrant 3, we know the angle is down here. We have no information about where exactly the terminal side is, and that doesn't matter. So long as we have the initial side on the positive x-axis and the terminal side somewhere in quadrant 3. Again, we need to make a triangle, so we join that to the x-axis. We happen to go up this time, that's fine. As long as when we make that triangle, we join it to the x-axis. The information we have is that cosine of theta is negative 3 over 4, cosine being adjacent over the hypotenuse, but we don't know which one has the negative associated with it. So the adjacent, it could be 3, could be negative 3. Hypotenuse could be 4, could be negative 4. We'll deal with that in a moment. We're always looking at our angle from right here in the middle at the origin. The adjacent side to that angle will be the top side in this case. The hypotenuse will be down here. And now we need to decide which one of those will be the negative. Well, what we know is that the hypotenuse can never be negative. So we can't have a negative for the hypotenuse, it must be 4. So process of elimination tells us that the adjacent has to be negative 3. The other piece of evidence pointing us to that is that the adjacent side is on the left side, the negative side of the x-axis. Now, in order to find the exact values of sine theta and tan theta, we need the third side, we need the opposite side. And again, we have two sides of a right triangle, so Pythagorean theorem comes into play. This time we know the hypotenuse, so I'm going to call A negative 3, B will be what we don't know, and C will be 4. Negative 3 squared is 9, 4 squared is 16. If we subtract 9 from both sides, we get b squared equals 7. Square root both sides, and b equals the square root of 7. We can't take the square root of 7. We can't simplify it at all, so b is the square root of 7, which I will label on the triangle. But it won't be just the square root of 7. Because we're in quadrant 3 and we're below the x-axis, that height, those y's, will be negative. So it's actually going to be negative square root of 7. Now going to answering the actual question. Sine of theta, opposite over the hypotenuse. The opposite side from that angle is negative root 7. Hypotenuse is 4. Can't simplify that at all. It's perfectly fine to leave root signs on the top, just not on the bottom. So sine of theta is negative root 7 over 4. Done. Tangent of theta, opposite over adjacent. Opposite side still negative root 7. Adjacent side is negative 3. One tiny bit of simplifying here. We have the two negatives that we can cancel out. So tangent theta is root 7 over 3.